Hello and welcome to another video. In this video, we're going to be working on apply operations to make the string empty from biweekly contest 124. And in the problem, you're given a string s, and you can do this operation until s becomes empty. Remove every alphabet character from A to Z, remove the first occurrence in it in s if it exists. So for example, they kind of show you here. So if you have A, B, C, B, B, C, A, you would remove the first A, the first B, the first C, you would get this. Then you would do it again, you'd get this. And then you would finally remove each one of these because that's all that's left, and you just return an empty string. And so they want you to return the value of s right before applying the last one. So they want you to return this. So in this first example, it's BA, and then in A, B, C, D, every single letter has a count of 1. So after doing one operation, you would just remove the whole thing. So the basic thing in this problem is you can kind of figure out that the characters with the biggest count will get removed last. So if our string has like 4 A's and 3 B's, then the order doesn't really matter. Like after every operation, we'll remove an A. So we'll have 3 and then 2, right? So this is one operation. Then after one more, we'll have 1 and 2. And then after one more, we'll have 1A and 0 B's. So it doesn't really matter like the order of our word, right? Like we can have this, A, B, 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 and we can say like, okay, well, let's just do this operation. So this is 1, 2, 3, but the order doesn't really matter. Like this can be in any order you want. So I could have had it like this. And if you do this, it'll be the same thing. So let's take a look. So we remove a B and an A is one operation, second operation, third operation. We still have this A. So the only thing that the order matters for is the character with the highest count. Because if you had characters with an equal count, like let's say you had AAB, or like this, AABBB, versus this, let's say, this would change it, right? So if we do this operation here, so we do this once, twice, now we have AB, and that's going to be the very last thing until we return. But if you do it here, you'll do this once, twice, and now you have BA. So that's the only thing that really matters, is you want to figure out where the characters are that have the biggest count, and also because you're removing the first character at a time, you only need to know like where they are, where is the last occurrence of them in relation to other characters that also occur the most. So if we go back to this thing, really all we need to know is like where's the last B and where's the last A, and that will be our final string. So the basic idea is we can get a counter of all the letters as we go through this. And what we can do is we can actually do this in place. It's kind of clever. So what we can do is we can keep track of a counter of letters, and we can just store an array of our final string. And the way that's going to work is anytime we hit a letter that has our max count, we're going to put it into the array. So we're going to traverse this word. Anytime we hit a letter that has a max count, we're going to put it into our array. And then whenever a new max count is reached, we'll say like, well, everything in there before has a smaller count, so we can toss all that, and then we'll make a new array. And at the very end, your array will already be the sorted string. So let's look at an example of this right here just to show you. So if we have like AA, BC, BB, CA, essentially we're going to have a counter, right? So we're going to go through the first letter. We're going to check what's the count of A. The count of A is 1, and that's our new biggest count, right? We didn't have a biggest count. So we're going to have an array of characters. We're going to say, okay, well, we have a new biggest count, so we're going to take whatever we had, toss all that, put in an A. Then we go to the next A, and we say A has a count of 2. Okay, well, that's our new biggest count, so we're going to take whatever we had in our old array, toss all that, put it in A. Because like I said, the only thing that matters, the only thing that will remain at the end, like if your array is only A's, the only thing that will remain at the end is the very last occurrence of an A. So that's why anytime the count of something increases, we just check like, is that equal to our biggest count so far? And we can write that right here. And if it is, then we'll add it into the array. And if it's bigger, then we'll just toss out our old array, because the only thing that will remain is letters with the biggest count if you're removing one at a time. So then we go to this B, and we're going to say, okay, B has a count of 1, but our biggest count is 2. So this letter won't remain if we only have one B, so we don't really care about it. So then for C, C has a count of 1. Once again, we don't really care. Now we go to this next B. Now this has a count of 2. So now this does reach our max count. So we know that like after, like this will remain in the second to last deletion. So we do have to add the B in now. Then we go to this B and we say, okay, what's the count now? So the count is 3. So now we have a new biggest count. So because we have a new biggest count, that means that everything before won't stay in here, right? Like this A over here with a count of 2 won't stay. This C with a count of 1 won't stay because B has a count of 3. So after 2 deletions, the only thing left will be a B. So we can, once again, when we get a new biggest count, we can make a new array, put in a B. Then we go to a C, count of 2, don't really care because our biggest count is 3. So we know that a C won't be in our final array. And finally for the A, our biggest count, or our count of A's is now 3. So because our count of A's is 3, we know the A will remain and we'll add it in. And then finally, we can just return this array joined up as a string. And that's basically it. And if you do this A, B, C, D, then basically the count of each letter would be 1. So you would just put in like an A1, B1, C1, D1, and you would return this. So that's kind of like the clever way of doing it in like a one pass. You basically just know that the only letter that will remain is the letter with the biggest count. So anytime I get a new biggest count, I can delete everything else because those will all get deleted. And I can just store all the letters with the biggest count and then return that as a string. And so the code is really easy. You just have it counts. That's a default dict. You have the biggest count and a result array. And you go through all the letters and you check if the count of the letter is bigger than my biggest count, then I will delete my old array of characters and I'll just put in this character and I will update my biggest count. Otherwise, if it's equal, then I will add the character into the array. And finally, I can return this joined as a string. And we can submit, and it's pretty good. As far as like runtime, I don't really know how you can do better. I think you have to have counts. So it just comes down to like maybe some, like, it's still going to be O of n. You can't do better than O of n. So yeah, I don't think it matters too much. So yeah, for the runtime, this is going to be O of n because we're essentially looping through a character, and space. Worst case is actually going to be O of 1 because like we do have to have a result, right? Like we can't not have a result. I guess technically you might argue, well, no, actually no. So this result array will only be 26 characters max, right? Because anytime the count of any character increases, that character is overridden, right? So if we have like, let's say our array is like A, B, C, D, and then we hit any character that's in here already, that means these characters had the biggest count. So if the character is in here, that means we have a new biggest count, so we'll delete this. So our array can actually be, like our result can only be 26 characters. And this counts can only be 26 characters because it's only lowercase letters. So it's O of n space in, or O of n time in O of 1 space. Yeah, it's going to be all for this one. I'm going to do the next one soon, and I'm almost done with the last one. I kept running into edge cases, so I'll probably get all those out today. So thanks for watching, and if this was helpful, please like the video and subscribe to the channel.